One of the big things is you're going to be needing a scientific calculator for the rest of chapter or module 4. So make sure you bring one with you. Borrow one if you need to for the time being, but you will need it for the entire chapter 4. So today, on warm-up, we're stating the translations. So you're identifying reflections, compression, stretch, and vertical and horizontal shifts. So with number 1, remember the 3 because that's the base, that's the number that we ignore. So we have to come up with what the 0.5 does and what the -2 does. Well, the 0.5 is being multiplied, so that means either stretch or compression. 0.5 is between 0 and 1, so that's a compression, because remember stretch is numbers greater than 1. The -2, since that's not part of the exponent, that means it's a vertical shift. Vertical, we stay in the direction it tells us, so that minus tells us down. So vertical shift down 2 units. And there were your 2 parts to number 1. Number 2, this time, the number we ignore is the 4. We can't ignore the negative part of it, but just the 4. So we have to identify what the minus does, what the +1 does here, and what this -2 does here. So the minus sign, remember, that means it's a reflection, and it's over the x-axis. The +1 is part of the exponent, so that means horizontal. Horizontal is always the opposite. So since it's a plus, we would normally think right, but that means we have to think left. And then we have that -2 again. Well, that -2 is the same as in number 1. That's the vertical shift down 2 units. And there were your 2 answers to the warm-up today. Make sure you've graded it and fixed what you needed to and marked correct what was done right. Here are your answers. Here are your answers from last night's homework. Number 10 and 11, you were graphing. Number 10, that one doesn't have any transformations to it because there's no number besides that base of 4. Number 11, that's a compression because it's a 0.5, and that means your graph is going to get a little bit wider, the curve. So that's what 10 and 11 should look like. 12, 13, and 14, we didn't base it off of the graphs in the notes, but they did give you an equation in each one. So here was your equation. We had a -1 in the exponent, so that's horizontal shift right, because it's the opposite. 13, we had a 0.75 being multiplied, so that's a compression. And in 14, we had a negative, which means it's a reflection over the x-axis. And there were your homework problems from last night. We're still in 4-7, but we're going to do the second part to it. So take a moment to get the notes passed out. Today we're going to be talking about natural base exponential functions. These are an exponential function that have what we call a base of e. So instead of a number, it's the letter e. Now e is a variable, which means it represents a number. The number it represents is an irrational number, which means it never ends, which is why we just use the letter e to describe it. And we use this to describe our exponential growth or decay. To evaluate e to the x, we will be simply using your calculator. Now, on your calculator, you're looking for the button E, lowercase, and it should have e to the x, so it should look like this. Now, sometimes you push the e to the x first and then the exponent, and sometimes you push the exponent first and then the e to the x. So, e to the x should always be, or e to the 1, is approximately 2.7 18 dot dot dot. So in your calculators, see which way you have to push it to get 2.718. So either type in the 1 first and then hit the e to the x button, and for some of you might have to hit second and then e to the x, and then some of you might do e to the x first and then type in 1. Help each other out, and when your calculator has gotten 2.718 dot dot dot, you'll know how to enter it in your calculator. So go ahead, take a moment, and make sure everyone has it figured out for their calculator. So now that you should have that figured out, and if you don't, keep this paused until you're ready. We're going to do e to the 4th. So whichever way you typed it in to get e to the 1st is the same way you're going to type it in here. And e to the 4th should be 54.6. We're going to round it to the 10th. So we're going to round to the 10th for the next 3. So go ahead and do those, and then unpause this to check your 3 answers when you're ready. All right, the answers for the 3 you tries. The first one, e to the negative 2, should be 0.1. E to the 10th should be 22,026.5. Now, the third one you really didn't even need a calculator for, because anything to the 0 power is always 1. Doesn't matter what the number is. So there are your 3 answers to the U-tries. Well, we use E in a formula that we talk about with continuously compounded interest. Generally, simple interest, which is what you've seen before, is calculated once a year, or at the beginning of the loan. Continuously compounded interest means that every time the amount changes, the amount of interest also changes. So, to figure out this formula, the first thing we're going to do is define your variables. And then we're going to substitute the values into the formula. Now, one way to help you remember this formula is if you look at the right-hand side, it kind of spells the word PERT. So continuously compounded interest deals with PERT. And the problem itself will always say it. When it tells you the interest is compounded continuously, you'll know that you're using this formula. So our goal is to find the amount after the number of years that you've had it in the account. So we need to figure out what T is. P, we know E. E is always the 2.81. It's the button, or 71. It's the button in your calculator you're going to use, and R. And don't forget with R, just like in the formula we worked on the other day, you have to change the percent into a decimal. So our time here is the 4 years later. The principal, which means the beginning amount, is the 3,000. And our rate here is 5%. We can't put the percent in, so the 5, we move it 2 places to the left. So the rate is 0.05. So here we've defined our variables. So now we're going to substitute these in. So we have A of 4, which means the amount in 4 years, is equal to 3,000 times e to the RT, which is 4 times 0.05. Now there are basically two types of calculators. The ones where you put the exponent in first and then you hit the e, and then the ones where you hit the e first and then the exponent. So if your calculator is the kind where you hit the exponent first and then hit the e button, you're going to type this in backwards into your calculators. So you're going to go 4 times 0.05 and then hit your e button, whether it's e or second e, and then times 3,000. And you should have ended up with 3,664.208274, and so on. If you had the type of calculator where you put in the e first and then the exponent, this is your directions for your calculator. You're going to go 3,000, hit times, hit your e button, and then parenthesis 4 times 0.05, close the parenthesis and hit equals. And again, you should have 3,664.208274. So again, if you got that, help your neighbor figure out how to type it into their calculator correctly. If you didn't get it, please make sure you're asking a neighbor if they got it and for help. And then unpause this once everyone has this on their calculator. Now, because we're talking about money, and it also told us in the directions to round it to the nearest dollar, that means we're rounding it to where the 4 is. So I look at the number behind it, which is a 2. A 2 tells us to stay the same. So the amount in the account after 4 years would be 3,664. Okay, so now you have a U-try. You're going to use the same problem, but you're going to say how much money will you have at the end of high school, which means you're talking after another 4 years. So our difference here means that the time is 8. Your rate is still the same, which was 0.05, and the initial investment, your principal, is still 3,000. So go ahead and figure this problem out. Check with a neighbor to see if your answers agree. Help each other with your calculators as needed, and then unpause this to check your answer. So you should have set up the equation to say A of 8 equals 3,000 times e to the RT, so 0.05 times 8. And after you type that into your calculator, you should have had 4,475.47409. We're going to follow the same directions, which means to round to the nearest dollar. So we look at the 5. The number after the 5 is a 4, so we're staying the same again. So the amount after 8 years in that account would be $4,475. Now you're going to do the next U-try. So you're going to have to figure out your variables and then use them in the formula. Check with the neighbor and then unpause this to see if you did it correctly. So your variables in this case was P was 400, time was 1.5 years, so that means 1.5, and the rate, even though 7.6 was a decimal, it's still got the percent, so you have to move that 2 places to the left, so 0.0076. Usually that's what will throw you off if you're going to make a mistake there. So then it should have been A of 1.5 equals 400 times E to the 1.5 times 0.0076. And that gave you 448.30085. We're going to go ahead and round to nearest dollar again, which should simply be $448.